Far beyond Mars, way out in the orbit of the ringed planet Saturn, there's a small ice-covered moon doing something absolutely extraordinary. It's launching its own hidden ocean into space. These cosmic geysers, erupting from massive cracks in the ice, are blasting the essential ingredients for life right to our cosmic doorstep, giving us a tantalizing taste of an alien sea. This isn't science fiction. This is Enceladus, a tiny moon that has completely changed our search for life beyond Earth. For decades, it was just another frozen, forgettable satellite. Now we know it's a dynamic, active world, a prime candidate for finding life, hiding its biggest secrets under a shell of ice. So, how can a world so small and so far from the sun be this active? And what are its magnificent plumes telling us about the dark, global ocean that lurks below? Welcome to Mystic Space TV YouTube channel. When the Voyager spacecraft zipped through the Saturn system back in the 1980s, Enceladus was a bit of a head-scratcher. At only about 500 kilometers across, roughly the width of the United Kingdom, it was a tiny world. And yet, it was the most reflective body in the entire solar system, shining like a fresh blanket of snow. Parts of its surface were also weirdly smooth, suggesting something was actively resurfacing it, erasing the cosmic scars left by asteroid impacts. Another clue was its odd relationship with Saturn's E-ring. This faint, hazy ring of ice particles sits in the same orbit as Enceladus, and astronomers had a hunch the moon was somehow feeding it material. But how? A small frozen moon shouldn't have the kind of geological engine needed to continuously spray a ring into existence. For decades, Enceladus remained a bright, cold mystery, a beautiful but apparently lifeless ice ball. Nobody could have predicted the wild truth hiding just beneath the surface, waiting for a much closer look. That closer look came with the arrival of a dedicated explorer, a probe that would completely rewrite the book of this mysterious moon. In 2004, the Cassini spacecraft, a joint mission between NASA and the European Space Agency, pulled up to Saturn for a 13-year tour. In 2005, it turned its instruments toward Enceladus, and what it found was breathtaking. Cassini's magnetometer noticed something was bending Saturn's magnetic field around the moon, hinting at an atmosphere. Following that clue, the spacecraft zoomed in on the South Polar region and saw something that would change planetary science forever. Enormous fountain-like jets of water vapor and ice particles erupting from the surface and shooting hundreds of miles into space. Scientists were floored. They had discovered active cryovolcanoes, ice volcanoes, on a moon they thought was frozen solid. These eruptions were blasting out of 4 huge parallel fractures at the South Pole, quickly nicknamed the Tiger Stripes. These weren't just random cracks. They were vents for a massive plumbing system, powered by an internal heat source that science couldn't yet explain. Cassini didn't just see the plumes, it flew right through them, and with every pass, the story got more and more amazing. Analysis of the material revealed it was mostly water vapor, along with organic compounds, salts, and silica nanoparticles. The salt was a huge sign that the water was coming from a vast liquid ocean. The silica was even more telling. On Earth, silica nanoparticles form when hot, mineral-rich water from a rocky seafloor mixes with cooler water around it. This was the first hint of hydrothermal vents on Enceladus, environments just like the ones on our own planet, where life can thrive without any sunlight. However, some recent research suggests the plumes might not come directly from the ocean, but could instead erupt from a mushy zone of partially melted ice within the shell, making the process even more complex. Final confirmation of a global ocean came from gravity measurements and watching the moons wobble. As Enceladus orbits Saturn, it shimmies slightly on its axis. The wobble was too big for a solid body. The icy shell had to be sliding freely over a global liquid layer. The evidence was undeniable. Beneath an ice shell, now estimated to be about 20 to 23 kilometers thick at the North Pole and 25 to 28 kilometers thick on average, Enceladus hides a global ocean of salty water. A hidden sea, warmed by internal heat and interacting with a rocky core, was blasting its contents into space for us to sample. Discovering a global ocean was huge, but what Cassini found in it is what makes Enceladus arguably the most exciting place to search for life. The plumes contain the three key ingredients for life as we know it: liquid water, essential chemical elements, and an energy source. The water is there in the form of a massive salty ocean. The energy comes from two places: tidal flexing from Saturn's immense gravity, which kneads the moon's interior and creates heat, and chemical energy from those suspected hydrothermal vents. Recent discoveries have added another layer to this, revealing significant heat flowing from the North Pole, a place once thought to be inactive. This suggests a better heat balance across the moon, which could keep the ocean stable for billions of years. And then there are the chemicals. For years, scientists confirmed carbon, hydrogen, nitrogen, oxygen, and sulfur in the plumes. But one critical element was missing: phosphorus. Phosphorus is fundamental for life, essential for creating DNA, cell membranes, and the molecules that carry energy. For a while, its absence was a huge question mark. Then, in 2023, a reanalysis of Cassini data delivered the final piece of the puzzle. Scientists found clear evidence of phosphorus as phosphates inside the ejected ice grains. And it wasn't just there. Models suggest its concentration in Enceladus' ocean could be hundreds of times higher than in Earth's oceans. For the first time, all 6 essential elements for life have been found in an ocean beyond Earth. But the discoveries didn't stop. In late 2023, another deep dive into Cassini data revealed hydrogen cyanide. While toxic to us, this molecule is like a Swiss Army knife for prebiotic chemistry. It's a crucial precursor for forming amino acids, the building blocks of proteins. Its discovery suggests the ocean of Enceladus might not only sustain life, but could also host the very reactions that lead to its origin. Further analysis has continued to uncover a rich variety of other complex organic molecules, confirming that complex chemistry is actively happening in this alien sea. Enceladus isn't just a potentially habitable world, it's a world that is actively advertising its habitability by launching a chemical inventory of its ocean right at us. This raises one of the most thrilling questions in science. If life exists in the ocean of Enceladus, could evidence of it be in those plumes? We wouldn't have to drill through miles of ice to get to the ocean. The ocean is coming to us. This has made Enceladus a top priority for future exploration. Several missions have been proposed, with the Enceladus Orbilander being a leading concept. This ambitious NASA flagship mission would first orbit Enceladus for over a year, flying through the plumes with instruments far more advanced than Cassini's. Then, it would land on the surface for a 2-year mission, studying the ice to search for definitive signs of life. The European Space Agency is also seriously considering a mission, potentially launching in the 2040s to arrive in the early 2050s. These missions wouldn't just be looking for chemicals, they'd be looking for life itself. From a quiet, icy dot in the sky to a world of active geysers and a global, life-friendly ocean, the story of Enceladus is a stunning testament to exploration. With every pass, Cassini unveiled a world more complex and promising than we ever dreamed. It confirmed a global saltwater ocean, found evidence of hydrothermal vents, and detected all 6 essential elements for life, including tons of phosphorus and the key prebiotic molecule, hydrogen cyanide. Enceladus now stands as a beacon of possibility. It offers a unique opportunity in our solar system, an accessible ocean world that we can directly sample and study. We are on the verge of being able to answer one of humanity's oldest questions: are we alone? Future missions might one day catch a particle of ice from an Enceladus plume and find within it the unmistakable signature of life. Until then, Enceladus will keep orbiting Saturn, a tiny moon launching its immense secrets into space, begging us to come back and see what's hiding in its dark alien sea. What do you think we might find in the oceans of Enceladus? Let us know in the comments below.